In this collection of videos, we are going to talk about object-oriented programming, sometimes called OOP, and classes. Now first I'd like to talk about object-oriented programming because that's really the motivation behind studying classes. The image that I have over here on the screen is how many computer programmers view the users of their program. They view the users of their program as being somebody who might not be computer literate. And in fact, that's very true. We do not need people who use computers to totally understand all of the inner workings of the computer. None of that knowledge is necessary for someone to use the computer. Therefore, for two main reasons, one, we should not assume that our user has any internal knowledge of how a computer works because they don't need it. And two, because of the fact that our user does not have that understanding necessarily, it's possible that if we allowed them access to all the details and levers and pulleys and ifs that are behind the scenes, that they might unknowingly say, "What's this?" throw some keystrokes on the computer, and ruin what the program is meant to do. Now the magical solution for that conundrum is what we call object-oriented programming, where we make programs and software where the user gets a user experience that is fundamentally unchanged, and we hide all of the details of how something is working in the background, and there, as computer programmers, we can mess with that and change it and modify it as much as we want, and all the while the user is entirely unaware of any changes we might have made in the background, since that's information that they're not privy to. So just to reiterate on the main idea of object-oriented programming, the main idea is that we do not want our user to pay any attention to what's going on in the background. What we do want to do is create an experience where the user gets everything that they need from our software, but they don't need to understand or see or even be able to interact with the things that are going on behind the curtain. Now we've started hinting at some object-oriented programming practices already in previous videos and programming experiences. One way that we've created for users to use something without necessarily knowing what's going on is in defining functions, particularly when we make definitions of functions and place them in separate files and have the user load them in as a module. That's one method of abstraction, of taking the way that things work and hiding that from the user, putting it in a file that they cannot access, and just allowing them to use the function that we've written without modifying the function that we've written. Those three things in that particular order are sort of levels of advancement in our move towards object-oriented programming. We can take this one step further by defining whole mechanisms for interacting with data and using the computer in an object-oriented way with user-defined data types, otherwise known as classes. Now classes are user-defined data types, typically more complicated data types than the computer can represent with its individual built-in data types like integers, floats, strings, and Boolean data types. How we usually think about classes are encapsulations or collections of many individual data types that constitute a larger object. So these smaller data types that we encapsulate into one functioning unit that are part of a class are called attributes of the class. We can also define functions that we might only want to use on class objects that we know have these various parts, and those functions can belong to the class as well. And in that circumstance where we write functions as part of a class, and we think of the functions as belonging to the class, we call those functions methods. So I've done a very small example here to clarify. For now, let's totally ignore the syntax of what we have written here, and let's think about the bigger picture. What I've tried to do is define my own data type, and I'm thinking of my data type as a point in the Cartesian plane. Now, a point consists of two different atomic data types, both of which we'll think of as floats, which are the point's x position, or x coordinate, and the point's y coordinate, which we call y position. So the two attributes of the point class that I've defined here, again, ignore the syntax, just look for the bigger picture. I'm defining a new data type called a point. It consists of two encapsulated floating data points, an x coordinate and a y coordinate. I've also defined a method, which is this distance function, which says when I have a given point in the Cartesian plane, I often want to know the distance from that point to the most special point in the Cartesian plane, which is the origin. And so it may not make sense to compute a distance to the origin in a random computer function, but whenever I have a point in Cartesian space, it does make sense to define this distance function. So we define the distance function from within the class. And we make that definition right here, and we would think of this distance function as being a method of the point class. Last but not least on vocabulary for now, something we'll examine in the next video, we are using classes in order to define our own data types. It's very plausible then that in our computer program we might want to declare objects of this particular data type, and in fact that's the verbiage that we use when we create a variable of our class type. We call such a thing either an object or an instance of this class.